Good morning, my dear students. So, in this lecture video, I am going to derive a Hermit shape function for a given element. Okay, so this question is very important. Okay, even if you look at the 3-2 year question paper, so this question will be there among every semester. Okay, I think this is most important question. Every semester, this question is asking in the university examination. Okay, derive an expression for Hermit shape function. Okay, so after seeing the lecture on this video, the previous lecture video, that is the Hermit shape function and what are the formulas and what are the notation, then after studying that, we need to derive this equation. Okay, so Hermit shape function is nothing but what I already told in the previous lecture video. So Hermit shape function, it states that what, so here the transverse displacement and the slope of a slope are continuously present on that particular given element. Okay, so that is called as a Hermit shape function. Okay, so here it is also called as a what, the interpolation function. Okay, so Hermit shape function is also called as interpolation function, and it is denoted by capital H1, H2, H3, H4. Okay, so if the single element is there, means we are going to call as what, the shape function will be present on that particular element is equal to H1, H2, H3, H4. Okay, look at this. This is what I am going to derive this equation today class. This equation, okay, Hermit shape function for the given beam element. Okay, so Hermit shape function are also called as an interpolation function. Okay, so it states that what, that the transfer displacement and the slope continuous over the given beam element, okay, is called as Hermit shape function, and it is denoted by H1, H2, H3, H4 for 1D element. Okay, so look at this. So this is the what, before starting this derivation, let me understand this diagram. Okay, so here question is given like this. Okay, so derive an expression for Hermit shape function for the beam element. This is most important. Okay, below figure shows what the beam element having two nodes, node number 1, node number 2. Okay, each node there will be having 2 degree of freedom, v1 and theta 1, v2 and theta 2. Okay, so already I told you, so if you consider in the natural coordinate system, so the center should be in the origin of the given beam element. Okay, so that is here at point 1. So here zeta is equal to 0. So here at node number 1, zeta value we are going to take as what, the -1. At node number 2, zeta value is equal to 1. Okay, so here v1 and v2 are the vertical, that is a translation displacement, and theta 1 and theta 2 are the what, the rotation displacement. Okay, so which is equal to dv by dx, and theta 2 which is equal to dv by dx. Okay, so this is the slope we are going to get while solving the problem. Okay, so this is about the brief diagram expression about the diagram. So this the beam element, the length is what, LE. Okay, so LE denotes what, the length of the given beam element. Okay, so this is the x direction and y direction. If you consider local direction, so origin will be denoted at the center, that is zeta is equal to 0, and at node number 1 zeta value is equal to -1, at node number zeta is equal to 1. Okay, so calculating the Hermit shape function and substituting the final equation, you are going to get what, the Hermit shape function for 1, 2, 3, 4. Okay, so look at this, the field variable that is maximum deflection, that is here the field variable maximum deflection in terms of the shape function, which is given by v is equal to h into q. Okay, so here v stands for the maximum deflection. Okay, so this is what the zeta, what you are going to denote, this is called as in a field variable. Okay, you need to calculate here the Hermit shape function. Okay, so the field variable v of x in terms of the shape function which is given by deflection v is equal to h into q. Okay, so where h is equal to what, so here the h is called as a Hermit shape function. So h1 is equal to Le by 2 h2, and h3 Le by 2 h4. Okay, so here h stands for this equation. Already this equation how we got means we already studied in the previous lecture video. Okay, so here we are going to apply the boundary condition. So calculate h1, so h2, h3, h4. Okay, so at each, by applying the boundary condition, you need to calculate h1, h2, h3, h4 and substitute in this equation. So you are going to get what, that is what, Hermit shape function for the given beam element. Okay, so where q stands for the nodal displacement vector, that is v1 theta 1, v3 theta 4. Okay, so this v1 and theta 1 is at node number 1, and this is actually, this is v2 theta 3. Okay, so at node number 2, these are the nodal displacement. I think it is wrong. Okay, so v1 v2, so v2 this is theta 2. Okay, so that is v1 v2 v3 v4. Okay, this is correct only. Okay, so v1 theta 1 at node number 1, and this is at node number 2. Okay, so that is transpose. We remove the transpose, you have to write the vertical. Okay, so now how to find the shape function. Okay, in all the 4 elements, that is h1, h2, h3, h4, same procedure is there. First, if you remember, if you know the how to calculate this shape function, means you can understand h2, h3, h4, h5, or that is h4. Okay, so same procedure is going to adapt in the this what, to while calculating this shape function. Okay, so to find the shape function at point h1, so we have the 2D element, that is assume a 2D, that is a polynomial function as h1 is equal to a0 plus a1 zeta plus a2 zeta square plus a3 zeta cube. Okay, give you question number 1. Okay, so where I already told in the module 1, so where a0, a1, a2, a3 with the generalized coordinate system that you need to calculate by applying the boundary condition. Okay, so at node number 1, So look at node number 1, h1 is equal to 1, zeta is equal to 1. These are the boundary condition. Okay, so at node number 1, so boundary condition h1 is equal to 1 and zeta is equal to -1. Substitute this equation in this equation, you are going to get this. Okay, that is h1 is equal to 1, a0 plus zeta is equal to -1 is there, so minus a1 plus a2 minus a3. So give equation number 2. Okay, differentiate this with respect to the zeta. So dou h1 by dou zeta, which is equal to what? So differentiation of this means this is equal to 0. So a1 plus 2 a2 zeta plus 3 a3 zeta square. Okay, so here apply the boundary condition again. So dou zeta 1 by dou h1 by dou zeta, which is equal to 0 and zeta is equal to -1. Okay, so these boundary condition we already calculated in the lecture video, the previous lecture video. Okay, that is Hermit shape function. Okay, so substitute these boundary condition in this equation, you are going to get 0 is equal to a1 minus 2 a2 plus 3 a3. Okay, give equation number B. Okay, similarly this is at point number 1 and at node number 1, these two are at node number 1. So similarly calculate the at node number 2. So at node number 2 is equal to what? h1 is equal to 0, zeta is equal to 1. Okay, so h1 is equal to 0, zeta is equal to 1. Substitute in this equation, you are going to get this equation, that is equation number C you are going to get. Okay, substitute here h1 is equal to 0, 0, so a0, okay, plus a1 plus a2 a3 you are going to get zeta is equal to 1. So similarly differentiate with respect to this, again apply the boundary condition dou h1 by dou zeta, which is equal to 0, zeta is equal to 1. Substitute this in this equation, so you are going to get the D equations. Okay, so that is 0 is equal to a1 plus 2 a2 plus 3 a3. Okay, so now after applying the boundary condition, after getting the 4 equation, so you have to add the alternate equation, that is A and this what? Yeah. So add the equation A and C and B and D. Okay, so after adding the equation A and C, so you are going to get this equation a0 plus a1 half. Okay, so and a1 is equal to minus 3 a3. Okay, F. Okay, so now substitute this E and F value in the equation number from the C, so you are going to get the a1 value, a2 value, a0 value. Okay, so a1 is equal to minus 3 by 4 and a2 is equal to 0, a0 is equal to 1 by 2. Okay, now these are the general, after calculating the general coordinate system, I substituted this in the Hermit shape function, that is equation number 1. So this is what the h1 is equal to this equation. So substitute here the values what you calculated here, so you are going to get this. Okay, so again you simplify this means shape function h1 is equal to 1 by 2 minus 3 zeta plus zeta q. Okay, so again if you want to simplify this, you are going to get this 1 by 4 1 minus zeta whole square plus 2 into zeta. Okay, this is what the Hermit shape function for node number 1. So this is very important. Okay, similarly you have to calculate the h2, h3, h4. Okay, so then h1, h2, h3, h4 are called as Hermit shape function. Okay, so same procedure you have to follow. First let us assume the polynomial displacement function, apply the boundary condition, substitute. Okay, so calculate the A, B, C, D value, add the A and C, D and D, substitute E and F value in the equation number the assumed polynomial and calculate, you are going to get the Hermit shape function. Okay, so look at same procedure you have to follow here also. Okay, so to find the shape function h2, so assume polynomial displacement modulus, so this one. Okay, h2 is equal to a0 plus a1 zeta plus a2 zeta square plus a3 zeta q. Okay, so at node number 1, so again h2 is equal to 0 and zeta is equal to 1. So these boundary condition I explained in the previous lecture video. Okay, so from that only we are going to consider this. Okay, so after putting this, you are going to get the A equation. Again differentiate with respect to zeta, so this dou h2 by dou zeta a1 plus 2 a2 zeta plus 3 a3 zeta square. Again you have to apply the boundary condition, that is dou h2 by dou zeta, which is equal to 1 and zeta is equal to -1. So substitute in this equation, you are going to get this what 1 equal to a1 minus 2 a2 plus 3 a3. Okay, so similarly you have to apply the boundary condition at node number 2, h2 is equal to 0 and zeta is equal to 1 and dou h2 by dou zeta, which is equal to 0, zeta is equal to 1. So substitute this, you are going to get what? Again two equation, that is E and F equation. Okay, so after adding A and C equation, you are going to get again adding the B and D equations. Okay, so you are going to get simply after simplify this, so you are going to get the new equation E and F. So substitute this E and F value in the equation, that is Hermit shape function. You are going to get, so what? So a1 is equal to -1 by 4, a0 is equal to 1 by 4, d is equal to, that is what? a2 is equal to -1 by 4. Okay, so these values substitute in the given equation, that is Hermit shape function equation, has for in the h2 equation. So h2 is equal to a0 plus a1 zeta plus a2 zeta square. Okay, you simplify the after substituting the value, simplify means you are going to get shape function h2 is equal to this. Okay, so this is the shape function for what? h2. Okay, like that you have to solve the, similarly you have to find the shape function at h3. So h3 is belong to at node number 2. Okay, so again assume this polynomial displacement function. Okay, so apply the boundary condition, h3 is equal to 0, zeta is equal to -1. So you are going to get the A equation. So again differentiate with respect to zeta, so again apply the boundary condition this 0 and zeta is equal to -1, you are going to get the B equation. Okay, so similarly at node number 2 h3 is equal to 1, zeta is equal to 1. So 1, so you are going to get, after applying the boundary condition, you are going to get the equation C and D. Okay, same procedure what you followed in the previous. Okay, add the A and C values, so you are going to get A naught plus A2 1 by 2. So add the B and D equation, you are going to get this. Okay, so substitute E and F value in equation number C, so you are going to get the A3 value, that is A3, A2 and A naught value. Okay, so these values substituted in the H3 equation, that is the Hermit shape function. In this equation you have to substitute, so you are going to get the shape function H3 is equal to 1 by 4 2 plus 3 zeta minus zeta cube. Okay, this is what the Hermit shape function. So similarly you have to find the shape function for H4 also. Okay, so here also it is belongs to that node number 2. So assume this displacement polynomial function, apply the boundary condition at node number 1 and at node number 2. At node number 1 H4 is equal to 0, zeta is equal to minus 1, calculate, you are going to get A equation. Okay, again apply the boundary condition dou H4 by dou zeta and apply the boundary condition, you are going to get the B equation. Okay, at node number 4 that is zeta 4 is equal to 0, zeta is equal to 1. Okay, so at node number dou H4 by dou zeta is equal to 1, zeta is equal to 1, so you are going to get the D equation. So again add A and C and B and D. Okay, so same procedure what you followed in the first Hermit shape function. Okay, so similar procedure is there. So you substitute the E and F value in equation number C, so half of you are going to get this. Okay, simplify this, you are going to get what, the A naught in A1 and A2 value. Okay, so A1 A naught A2 value you are going to get. So these values you substitute in the Hermit shape function H4. So H4 is equal to A naught plus A1 zeta plus A2 zeta square plus A3 zeta cube. Okay, after substituting this you are going to get the Hermit shape function is equal to H4 is equal to half of minus 1 minus zeta plus zeta square plus zeta cube. Okay, so these are the Hermit shape function values. Okay, if you write in standard way means, so we know that the Hermit shape function H is equal to H1 LE by H2 or H3 LE H4 by 2. Okay, so already we calculated H1 H2 H3 H2 value. Okay, substitute in this equation, H is equal to, this is a transpose, you can write this okay fashion. Okay, so after calculating this, so 1 by 4 2 minus 3 zeta plus zeta cube. Okay, so again if you simplified values, if you wrote means, okay, this is what the Hermit shape function. So this is H1, this is H2 H3 H4. Okay, so H1 is 1 by 4 1 minus zeta whole square plus 2 zeta, LE by 8 1 minus zeta whole square zeta plus 1, 1 by 4 1 plus zeta whole square 2 minus zeta, LE by 8 1 plus zeta square zeta minus 1. Okay, so this is H1 H2 H3 H4. Okay, so this equation we are going to call as the Hermit shape function of a given beam element. Okay, so that is one dimensional, that is 1D element beam element. Okay, so 2D beam element. Okay, so this is most important question. Okay, based on this only we have to solve the numerical problems. Okay, so we have to remember this H is equal to Hermit shape function for H1 H2 H3 H4. Okay, so now, so the variation of a shape function is equal to how many? Okay, so like this n1 n2 n3 m4. Okay, n1 n2 n3 n4 are called as a shape function. So for the first element, so here the Hermit shape function is maximum. Okay, so remaining is 0 is there, so draw the linear curve. Okay, so coming to this, okay, v1 and here the what, the theta 1 will be there. So theta 1 and 2. Okay, v2 theta is completely 0, but here the rotation angle will be there at node number 1. Okay, the rotation displacement is there, so you have to draw here curve, that is v1 is equal to 0, theta 1 is equal to 0. Okay, like that here similarly same opposite of this. Okay, so h3 at maximum value is 1, so another is 0. Again here the rotational displacement, what, here the 1 will be there, the rotational displacement theta is equal to 1, so here just you draw the 1 here, again it will linearly join at original position, that is origin. Okay, here 0 shape function will be there. Okay, so this is about the variation of shape function. Okay, so just you remember this one and this one, you have to draw the opposite of this. Okay, so this is for 1 and 2 is belongs to node number 1 and this belongs to at node number 2. Okay, so this is what, how we are going to derive the Hermit shape function for the given beam element. Okay, so you have to, from this slide what you understand means, so this Hermit shape function, what are the Hermit shape function and equations? Okay, so you have to remember these Hermit shape functions are very very important. Okay, so without this, if you are not understanding this means you cannot solve the numerical problems on Hermit shape function. Okay, and also it is very important derivation for the point of examination. Okay, so in examination they may ask you direct 12 mark question, derive an expression for Hermit shape function for the given beam element. Okay, so here, okay, so I hope you understand this derivation. Okay, you have to, unless if you are not practicing means you cannot solve. Okay, so this this, okay, you have to practice 2 or 3 times unless you become perfect. Okay, so thank you very much. Okay, thank you.